Hello dear viewers, welcome to TV Math. In our today's session, I will be taking you through one of the most important areas in pure mathematics, and that is trigonometry. So today we shall be talking about some of the common mistakes that students usually make while attempting questions in this area of trigonometry. This is very important, especially for those that are preparing for their final examination. So if you are in senior 6 doing mathematics, please make sure you stay around up to the end, because this is one of the important videos that will be discussing how best you can maximize all the marks from trigonometry. We know pure mathematics has got some of the important areas that you need to practice before your final examinations. You need to look at calculus, that is differentiation and integration, plus their applications, geometry. You need to talk about the vectors. You need to look at questions involving algebra, and most importantly, without forgetting, questions involving trigonometry. So today we want to begin with what we call some of the common mistakes that are usually done by the students within the area of trigonometry. So please don't forget to subscribe to this channel. Don't forget to like this video and share it with your friends. Let's get started. For those that are new to this channel, you are highly welcome, and please consider subscribing to TV Math, so as you can always get notified whenever we upload any new videos. In our today's session, I will be taking you through one of the important videos that you need to watch before doing your final examinations. So for those that are in senior 6, please consider subscribing to TV Math, especially those that are doing mathematics. I will be taking you through this journey as you prepare for your final examination. So together, let us make sure that we get that A in mathematics, and I will help you in achieving your goal. So what do we need to talk about in our today's session? We shall be talking about some of the common trigonometry mistakes in UACE Mathematics. So basically, we shall look at some of the examples of such mistakes and how best we can avoid them. Doing that, it means we shall be able to maximize most of the marks that are to come from this part of trigonometry. And if we do that, then we shall be able to pass mathematics with flying colors. So basically, what are the expected questions in your final examination? You expect to have one question in section A that is taking 5 marks. You expect to find one question in section B that is taking 12 marks. However, the use and the knowledge of trigonometry might not only help you in answering these two questions that are taking 17 marks. The knowledge of trigonometry will also help you in some of the other areas, especially in what we call the calculus. When you are looking at integration of trig functions, differentiation of trig functions, differential equations, you will always meet some of the questions that are involving trigonometry, meaning that understanding and minimizing mistakes in trigonometry will help you to achieve even more than 17 marks in the final paper. So let us look at some of the common mistakes, and we shall begin with the first one, which is about mixing degrees and radians. What is the mistake that majority of the students usually do? One is to use wrong mode on the calculator, and this will lead to wrong answers. How does that one happen? You are solving an equation. Which equation is sine of x is equal to 0.5. So we want to solve sine of x equaling to 0.5, but our calculator is in radian mode, and yet we expect a degree answer. So how do we make a mistake there? So we are saying our calculator is in radians, but we need to get our answer in degrees. So if the question is to solve sine of x equaling to 0.5 for the values of x less or equal to values of x greater or equal to 0, less or equal to 360 degrees. We expect the value of x to be in degrees. However, our calculator is reading rad. So how will the two differ? So let us try to solve that when our calculator is in radians. So what is sine of x equaling? Sine of x is equal to 0.5, meaning x is sine inverse of 0.5. So what will be the value of x? So the value of x, we are getting sine inverse of 0.5, and the value of x we are getting is 0.5236. This is the value of x you are getting. Because our calculator is in rad, you are getting this answer. So when you conclude with this answer will be wrong. Because what the answer we need is should be in degrees, but the answer we are giving is actually in radians. So for this question, you will get a wrong answer. So the answer will be wrong, though the methods will be okay. So always check your calculator to ensure that it is in radians if you are looking for the radians. If the question requires you to find the angles in degrees, make sure your calculator is in degrees. So, but what would be the expected answer there? So it means we must change the calculator to be in radians. And when you put that in radians, you will get the value of x. When you put your calculator in degrees, you will get the value of x as 30 degrees. So you realize the difference. This is 0.526, and yet the answer we require is in degrees. So for this case, it means that the answers that you are getting depends on the mode where your calculator is in. So if you only give 0.5236 and yet the answer is required to be in degrees, then you'll be getting wrong answers. So what do I emphasize here? I will emphasize that always check to see whether your calculator is in radians if you want to get answers in radians, and it is in degrees if you are interested in degrees. So that will depend on how the question will be asked. We shall talk about that one more. So next, let us look at these two examples. So they are saying solve the equation which is cos of 2x minus pi by 4, which is equal to negative 0.2. I will assume that at the moment you know how to solve this expression, and my interest is on the required values of x. So from this, we are given cos of this is equal to 0.2, which is a minus, but the required answer for x should be from 0 to 2 pi. So what does this condition mean? This condition tells us that a radian solution is required, meaning that whatever you are doing here, it is better to have or to make sure that you conclude with the values of x which are in radians. Don't conclude with degrees. I hope that one is understood. So whenever you have such a condition, it means 0, they want the values of x in radians. So it means you need to give a radian solution. And it means when you are getting the radian solution, then your calculator should be in what we call the rad mode. So in that way, you'll be able to get the correct answers. However, the same question can be said when you are having such an expression. This condition here, 0 less or equal to x less or equal to 360 degrees. So this condition tells you that the degree solution is required, and for that case it is better to have your calculator in a deg. So we have got those two important modes, the deg and the rad. So this is when you are required to present your answer like this. Deg is important when you want your answers in degrees. So the next important thing we need to talk about here is how best can I convert degrees to radians or radians to degrees. A very important expression to always remember is that pi radians represent or are equal to 180 degrees. And as well, 1 degree is same as pi by 180 radians. So whenever you have x degrees and you want this in what we call the radians, simply get pi out of 180 multiplied by your x. What you get here will be in radians. So let us look at, maybe you want to convert 30 degrees to be in radians. So this will be same as pi out of 180 times 30. And what you will get here by 30 is 1 by 36. That is 1 upon 6 pi. Now this one is in radians. So it means if you deal with your expression or your angles in degrees, and what you are required is the angle in radians, you can as well put it in radians by using this format of changing degrees to radians. So likewise, you can get radians, you put them to degrees or degrees to radians, so long as you use this given condition that pi radians are equal to 180 degrees. So always check your calculators to see the mode you are using when you are in the final examination. Don't forget that, otherwise it can cost you some marks. Next, let us talk about another common mistake that most students usually make. That is losing solutions by dividing early. How does that one happen? The mistake can be to divide. The mistake can be to divide by sine, cos, or any other. It can be cosec too soon, which might lead to missing some of the solutions, especially where they are equal to 0. Let us look at one of the examples here and see how we can lose some marks. You are having, for example, 4 sine of 2x, which is equal to sine of x. We know sine 2x is same as 2 sine of x cos of x. So this is equal to sine of x. So you are having 8 sine of x cos of x, which is equal to sine of x. And when you reach here, because sine of x is here, sine of x is there, you say, no, without wasting time, let me divide through by sine of x. So it means this and this cancels. You have 8 cos of x, which is equal to 1. So you go on and say cos of x is equal to 1 divided by 8. You go on, you say x is cos inverse of 1 divided by 8. But this was to be solved for 0 degrees less or equal to x less or equal to 360 degrees. Now, you go on and get your answers. You look for other answers where cos is positive. So you get your answer there, your answer here. So you get this answer, you go on and get that answer. You conclude very okay that I have got these answers and I have passed. So which mistake have you made here? Let us go on and look at someone else. Another person reaches here and says, I have 8 sine of x cos of x equaling to sine of x. Instead of dividing through by sine of x, you bring this one on the other side. So you have 8 sine of x cos of x minus sine of x, which is equal to 0. So you go on and say sine of x into 8 cos of x minus 1 is equal to 0. Then you have sine of x is equal to 0, or 8 cos of x is equal to 1. So you go on and get the values of x where sine is 0, that is 0 degrees, 180 degrees, and 360 degrees. So we know sine is 0 along the x-axis. Any angle here, sine is 0. Any angle here, sine is 0. So you have your values here. But you also go on and you have your x as cos inverse of 1 divided by 8. So you are having angles that this person got here, but you are having extra angles of 0 degrees, 180 degrees, 360 degrees that this person will not have. So you can see the difference. So this person will have about 5 angles. This person will have only 2 angles for this given range. This is the same range, but you are getting different answers. So here, this person divided very early. So at this given point, you divided so fast that you eliminated some of the angles. So this person here will lose many marks here. We lose the marks that this person will get when you are simplifying this, when you are getting the value or the angles for x when sine of x is 0. So whenever you are having such expressions in trigonometry, please don't always divide so soon. Divide where it is actually to divide. You have to ensure that that is the only option you are having to solve that given equation. But otherwise, don't make that mistake of dividing through so early that you will be able to miss out some of the solutions. So I will be saying that it is important to always factor first. Factorize, then after factorizing, equate each of the cases to 0 in case you are equating it to 0. So make sure you avoid the mistake of losing solutions by dividing so early. Next, another mistake that is usually done is losing solutions when you are taking square root. So let us also go through one of the examples and see how you can easily lose some of the marks, especially when you take square root and you don't consider some of the cases. Now, let us talk about taking square root. So when you are taking square root in trigonometry especially, not only trigonometry and in almost all the cases, whenever you have x squared is equal to 2, maybe 4, take square root, but remember that square root of a number is always a plus or a minus. So when you are taking square root of 4, don't forget that square root of 4 is a plus or a minus 2. Then if you want to get the required answer, all of them might be satisfying or not. Then check whether all of them are satisfying. But whenever you take square root of a number, please always consider positive or a minus. Maybe factor you are dealing with distances where you need a positive value. So let us look at how best you can lose some of the solutions when you are taking the square root. Now, let us begin by solving this. We are having sine squared of theta, which is equal to 1. So someone does this one very fast, takes square root on both sides, and says sine of theta is equal to 1. So goes on and says sine inverse of 1. For this required range, sine inverse of 1 will be 90 degrees. So this will be your solution. But someone else who does the same says that sine of theta, after taking square root here of 1, I say it is a plus or a minus. So sine of theta will be equal to positive 1, or else sine of theta will be equal to negative 1. Because here you are getting sine of theta is equal to plus or minus 1. So from here you say theta is sine inverse of 1, which is 90 degrees, or else sine inverse of negative 1, where you have 270 degrees. So this person here is getting 90 degrees and 270 degrees. But this person will only get 90 degrees. So you realize that when you take square root here, you are eliminating some of the solutions. And you can easily see that a solution like 270 degrees is actually eliminated. Now, you need to be careful when you are looking at square root or you are taking square root of a number in trigonometry. If you are not careful, you will be losing most of the solutions. So whenever you take square root in trigonometry, please don't forget that square root of a number is a plus or a minus. Always remember that. So how to avoid such mistakes? Always include plus or minus when taking the square root of any number. And when you are dealing with trigonometry, very important. Otherwise, you'll be losing some of the important solutions. So next we need to talk about some of the students who give only principal solution. So what is the mistake that is usually done? One is that you only write one solution. That is the principal solution. Then you ignore the periodic nature of the trig functions. We shall do this by using an example. For example, you are interested in obtaining the value for x where cos of x is equal to a half. So where cos of x is equal to a half, our x here will be cos inverse of a half. So when you get that, it means your x will be, let us get cos inverse of 0.5. So cos inverse of 0.5 will give us 60 degrees. So this is 60 degrees. And I assume you already know the difference between degrees and radians. So our calculator now is in deg, and we are interested in all the solutions for x which lies in this range from 0 less or equal to x less or equal to 360 degrees. But because you are at a very high speed, you only give this as your answer. So when you give only this as your answer, which is the principal solution, then your answer will be wrong, because you have not exhausted all the required angles. So what do? Trigonometry has got what we call a periodic nature. So we have got different quadrants where we have all students take chemistry. So that is simply a short form. So we have, someone can say this is cast beginning from here and going like that. So you need to understand that this is our first quadrant, the second quadrant, the third, and the fourth quadrant. So the angle that you have given is only the angle which is what we call the principal angle, and that is the 60 degrees. You have only given the angle here, but we have another quadrant where cos is positive. Cos is positive in this quadrant. So also the angle that lies in this quadrant, which is same as moving from here up to this given point, which angle is same as 300 degrees, is also satisfying. So when you only give 60 degrees, you will have eliminated another angle which is 300 degrees. So if you only give that and someone else gives 60 degrees and 300 degrees, this will be the right solution. But when you only give this, which is now the principal angle, your solution will be wrong. So you will not get all the marks. So you need to be careful. Don't always give only one answer, which is the principal solution. Always look at the range that you are given. Then that range will tell you exactly which angles I need to consider. But you need to be considering what we call the quadrants. So be careful, look at what range you're given, and then based on that range to get all the required angles. So that is one of the common mistakes. And also, before we leave this, it is important to as well talk about the intervals. So you are given cos of x equaling to this, but this here, this angle here can change. Maybe you have cos of 2x which is equal to a half. So when you get 2x here, it will be cos inverse of a half, and you are getting your 2x as 60 degrees. Another common mistake, don't divide from here and you get your x as 30 degrees, then you put on the quadrants 30 degrees. That one will be wrong. So don't divide at this given point. So at this given point, first get all the corresponding angles where cos is a half, and that is where 2x is equal to 6 at 60 degrees. So whenever the coefficient of x changes from 1 and your range is 0 degrees less or equal to x less or equal to 360 degrees, whenever your x changes or the coefficient of x changes, make sure that you get a new range to avoid making mistakes. So don't come here because you have 2x is equal to 60 degrees, you only put 60 degrees here, then you put another 60 degrees here, and this you say maybe my 2x is equal to 60 degrees and then 300 degrees. This still will be wrong. The solution you'll get here will still be wrong. So another person, when it reaches here, another person will simply say 2x is equal to 60 degrees, then you divide by 2 here, then you get x as 30 degrees. When you do this and represent this one as 30 degrees, this one as 30 degrees where cos is positive, this one will be automatically wrong. So don't divide at this given point. First use the angle that you have obtained to get all the required angles. So what I emphasize here is whenever the coefficient of x changes here, make sure you get a new range. So I have 0 less or equal to x less or equal to 360 degrees. So I must get the range for 2x. How do I get that? I need to use the given range to get a new range. So what will be my new range? Such that I get all the satisfying angles. My new range will be same as multiplying by 2 throughout, because I need to create 2x. So multiply by 2 throughout. So your new range is 0 degrees less or equal to 2x less or equal to 720 degrees. Meaning that they are not only these angles satisfying, but you also have other angles so long as they lie in this range of 0 degrees to 720 degrees. Meaning that your first angle will be this, your next angle will be from here up to here, which is 300. But again, this angle here, when you move again up to this given point, that is same as 360 plus 60, that is 420, will also be satisfied. So meaning on top of this, we have some other angles like 420, also another angle when you move and come back to this given point, that is 720 minus 60 degrees. Also that angle will qualify. So you realize that you have more than 2 angles here. So you have only also 660 degrees. So 60 degrees, 300 degrees, 420 degrees will all give you the required what? The required answer. So when your x changes, make sure you also get the new range, and that is the range which will help you to cater for all the angles. As I said, when you reach here, don't first divide through, and when you also reach here, you have 2x, don't only get 2 angles, restricting yourself to the given range. First get the new range, then from the new range you'll be able to get the required what? The required answer. So the range can change. You can have, for example, you can have a cos of x minus 30 degrees, which is equal to a half. When you solve this, you are getting x as x minus 30 degrees, which is equal to 60 degrees. Another thing, don't manipulate this before you get all the required angles. So what was the given range? It was 0 degrees less or equal to x less or equal to 360 degrees. So what will be the new range? This is the given range, but your x here is changing. It is now x minus 30 degrees. So you need to create the range for x minus 30 degrees. So how do you do that? First create x minus 30 by subtracting 30. If you subtract 30 there, then you must do the same here. So this is minus 30. So you have negative 30 degrees less or equal to x minus 30 degrees less or equal to 330 degrees. This implies that the required values for x minus 30 must range from negative 30 degrees to 330 degrees. So if you only restrict yourself to this angle here, you might lose out some of the angles. So it is always important, if your x here changes, especially when you have you reach at this given point, don't first manipulate this to get this one on the other side, then you get the corresponding angles corresponding to 90. That will be wrong. So first use the 60 degrees to get all the required angles where x minus 30 degrees lies, meaning those are the angles between negative 30 degrees and 330 degrees. Above that or below this, they will not qualify. So I hope the issue for giving only principal solution, also for looking at the given range, is now solved. So you need to be careful when you are dealing with trigonometric equations. So how do we avoid that? Write general solution first, then restrict to given interval. Always use the given interval to modify the required interval. So that will be done, and I hope everyone has understood what basically we have talked about. Next, we need to talk about wrong signs in quadrants. How does that one happen? You are using positive cosine or sine when the angle in the quadrant is supposed maybe to be negative. For example, they are telling you that if sine of x is equal to this and x is obtuse, then what should happen to cos of x? So that brings back to the quadrants. x is obtuse, you must know if x is obtuse, where is x supposed to be? And in this quadrant, what is happening to sine? What is happening to cos? What is happening to tan? In this quadrant here, sine is positive, but cos must be negative, tan must be negative. So you need to be careful. If they tell you sine of x is this and x is obtuse, then that implies that cos of x must be negative, tan of x must be negative. So in this quadrant, only sine is positive and it's reciprocal, but others are negative. So you have to be careful. If they say x is obtuse, x is acute, x is a reflex, you must know what happens to sine. Sine must be minus, sine must be positive, or it is the other way around. So always be careful when you are using quadrants. And some of these angles, especially when they talk about an acute angle, they talk about an obtuse angle, they talk about a reflex angle. Something must happen to sine, must happen to cos, must happen to tan, and that is about the signs. So signs must change. If they don't, it means you get wrong answers. So wrong signs in quadrants will bring about wrong answers. Simply something like a positive or a negative, these two can make your solution wrong. So if you use positive yet in the quadrant is the value must be a negative, then your answer will be wrong. So if they tell you that sine of x is 5/13 and x is obtuse, but for you only get the value of cos, and you also say that cos is positive, because in that quadrant, let us try to have that. We are having x is obtuse, so it is in this quadrant. Sine is opposite over hypotenuse, so this is your 13, this is your 5, meaning here you have 12. So what will be cos of x here? Cos of x, if you simply write 12/13, this becomes wrong. So cos of x here must be minus. If you are dealing with tan of x in that quadrant, tan of x must be 5. If you say 5 over, that is opposite over adjacent, 5/12, and you simply say it is 5/12, this will be wrong until you use a what? A minus. So you need to be careful when you are looking at quadrants. A sign can make your solution to be wrong. A plus or a minus can make your solution to be wrong. So you need to be careful there. So how do we avoid that? Always use the quadrants first. As we said, the quadrants, you can use cast. That is to easily know what will happen to the sign for cos. Here all are positive, sign is positive here. All students take tan is positive here, C cos is positive here. So you have all of them positive, tan is positive, others are negative. Here cos is positive, others are negative. So whenever you specify a quadrant, know what should happen to what? Know what should happen to cos, to tan, and to sine. And they are reciprocals as well. So you need to check the sign before using Pythagoras. So especially if you come here and you simply say sine of x is that, so cos of x will simply be the square root of 1 minus sine squared. And you put this, you will forget that your solution must be a negative. So you need to be careful, especially before applying the Pythagorean identity. So next, let us look at the next. So the next observation is when you are looking at proofs. So the mistake majority usually do is to manipulate both sides at once. This will you will actually be making circular arguments. So you are given the left hand side and the right hand side, but you begin with both the left hand side and the right hand side. So if you are proving maybe sine 3x is equal to, then you have your expression here. Don't again put sine of 3x is equal to this. Then you again manipulate this. Sine of 2x plus x again is equal to that. This will be wrong. So you have to be extra careful. So when you are stating or you are starting what we call the proof, make sure you start with one side. Either start with the left hand side or start with the right hand side and get the other side. But don't make such arguments by equating this to what you are proving, and you go on again equating the two. One side must give you another side. So what I emphasize here is that always start with one side. Usually the more complicated side is always the best side to start with, and simplify step by step. When you do that, you will be able to manipulate it well, and you'll be able to get the correct answer. So always start from one side, especially the complicated one. That is the one which is easier to prove. So next we look at the next, that is about misreading notations, that is powers and inverses. So what usually happens here is that you are given sine x squared is equal to a value, for example 0.5, but for you are treating this as sine of x, which is squared, is equal to 0.5. So you will be getting different answers. So here someone is supposed to say x squared is simply sine inverse of that. Now here someone is simply again taking the square root, so you can easily see the difference of that. So here the answers you will get will be automatically different. So you need to be careful. If you are given sine of x squared, don't treat it as sine of x everything squared. If you are given cos inverse, so another mistake that most students usually make is especially on the cos inverse. So you treat cos inverse of x as 1 upon cos of x. This is purely wrong. So don't write cos inverse of x as 1 upon cos of x, though we know that x to the power negative 1 is same as 1 upon x, but don't write this as cos inverse of x is 1 upon cos of x. Maybe if at all you have cos of x to the power negative 1, so this you can write it as that, but otherwise cos inverse of x alone is not 1 upon cos of x. So you need to be careful there. The same applies to sine inverse, the same applies to tan inverse. Don't make that mistake, you'll be costing yourself. So we have an example here, sine of x squared equaling to 0.5. You should treat it as sine of x. It is only x which is squared, which is equal to 0.5. However, you should not make this mistake of writing this to be equivalent to this. The two are totally different, and we have seen that using the same example. You get totally different angles. So how to avoid? Use brackets or parentheses when you are writing. Clarify inverse as arc sine or arc cos. So writing cos inverse, you can say it is arc of cos. Arc to mean the inverse. So here you have to be careful, especially when you are dealing with the powers and the inverses in what we call trigonometry. Otherwise, you might lose marks out of that. So next we shall look at what are some of the key areas you need to focus on when you are preparing for your final examinations, especially in the area of trigonometry. You need to know some of the few things: how to convert degrees to radians, how to use SOHCAHTOA, that is to relate sine with the opposite hypotenuse, cos adjacent hypotenuse, tan opposite and adjacent. Then you need to know how to use a small angle approximations, what happens to sine of a small angle, cos of a small angle. So you must know that. Then trigonometric identities, you need to be knowing something to do with Pythagorean identities, a reciprocal, quotient. You need to practice how to simplify some of the expressions. Compound and double angles, you need to be knowing some of the expansions for sine of a plus or minus b, cos, tan, double angles, half angles. You need to be knowing some of these things. Then you need to talk about also solving trigonometric equations. How do I deal with general solutions, multiple angles, restricted ranges? You need to be practicing all these. Then applications of sine, cosine rule, area, getting an area of a triangle. Then also dealing with angles, especially in vectors, you need to be knowing all this. Then talk about the factor formulae, the T and R formulae, inverse trig functions, you need to focus on this area. So make sure at least you practice different questions from some of these areas, because basically that is the knowledge you will need, such that you are able to grab all the 17 marks and any other marks that might involve trigonometry. So basically some of the tips that you need basically in your preparation: you need to master proving identities, especially know which side am I supposed to begin with, and especially that is the complex side. Then try to simplify it step by step. For equations, try to isolate trig functions, find reference angles. Those are the important angles to help you get the general solution. Then use general solution and restrict yourself to the range which is given. Practice a lot of questions from different past papers, time to time. Test yourself, time yourself such that you are able to do these things within time, because the NAB exam will be strictly time oriented. So 3 hours you need to be done with everything. But as you practice, make sure you time yourself such that you are able to do this paper within time. Sketch diagrams, use unit circle for quadrant checks. So we have seen how to do that. So try to always draw those diagrams to help you, especially the quadrants, to help you in giving the correct answers. Then review mistakes after your preparations. Keep a book for trig journal, of course, to help you in some of the areas where you are making mistakes. Always note those areas, especially where you make a mistake, such that you don't make the same mistake. You should always go through to revise the same, such that you avoid making some of the mistakes. Otherwise, that is where we shall stop for today. For any other additional tips, I will be in position to upload. Make sure you subscribe, comment, and like this video. Make sure you share it with friends such that they are also in position to benefit from such tips, and they avoid the same mistakes that others have been doing, especially in these final hours of the examinations. Thank you so much. Make sure you don't forget to subscribe to this YouTube channel. More tips will be coming from other areas, such as calculus, what you need to do when you are differentiating, integrating, when you are looking at differential equations, vectors, what do you need to know, algebra, geometry, what exactly do you need to do such that you are able to pass.
Yeah.